Right, good morning, everybody. The second session of the GSE for today. And today, on this session, we've got Dan from Model 9. He's talking about a cost case. And what I would say is that if anybody's got any questions, please put them on the participant field, and what we will do is we'll try and answer them straight away. And if need be, I'll be very happy to unmute you. For reference, the session number is 4AR. And one of the things that I would actively encourage you to do is to ensure that you fill in the feedback, because the feedback is very important to GSE because it allows us to basically bring in these guys. I believe this is maybe one of the first sessions that Model 9 have presented, but Dan's going to be talking about slashing the mainframe management costs and reducing MSU by 90%. So I'd be interested in knowing a bit about that. So Dan, I'm going to hand it over to yourself.
Thank you, Jeff. So I will start by introduction. I'm Dan Sprung. I'm a Chief Business Officer at Model 9. With me is Ofer Baruch. He is Vice President Field Engineering in Model 9. And I want to thank Jeff for awarding us. We are #1 in the contest, which was who will have the longest title for a session. So thank you, we won the competition. We will talk about cost savings around the data management. Model 9, for whoever in the audience that doesn't know us, we are a data management software for mainframe environments. Today we will talk about, Ofer, the next slide, please. We will talk about the challenges today in the mainframe environment, how we suggest you can do things differently, and getting the most out of your mainframe. We will look after all of the cost consideration associated to the data management cost around the mainframe. We will share a real life example from a US bank, and feel free at the end or during the session to ask us questions. So to start, today's challenges, and I think around the COVID-19, it expedited the pressure for companies to reduce the cost. And it's across the board, and especially now with the mainframe, you need to reduce cost, you need to be more efficient without compromise, to do the right things and to bring innovation, to support the business and keep the lights running. So the data management challenges around the mainframe. The first point is that it's expensive, right? You need specialized hardware and software. There is not a lot of vendors that supports mainframe protocols, and that's why it costs more than open systems. It's complicated. It's like specific knowledge that you need to have with a lot of legacy tools, and you need to have deep dive understanding of how things work. And also the third thing is that it's a silo. It's different than the other things. It's not something that you can integrate easily to other environments, and it's like a standalone. We will cover 3 things around the mainframe modernization and cost reduction. The first cost reduction that we will discuss is the data protection. If it's the ATL and VTL replacement, the backup software alternative. We have a session in 2 days, by the way, that is talking about replacing some of the CA software with Model 9. The second thing is the data transformation and ETL tools, how you can take the mainframe data and run on all of the data, BI and data analytics tools in an easy way without consuming billable meat. So everything that we are doing is while reducing significantly the data management CPU cost. And we will explain that shortly during the presentation. And the third is cloud transformation and how you move the data to the cloud. I added here quotes from Gartner report that they published in September, just a couple of months ago, talking about organizations moving the data to the cloud and mainframe modernization and a lot of interesting things. If you want, I can share with you the report later. So if there are no questions, I will let Ofer get into the technical details and explain everything that I just discussed in the highlights.
Okay, cool. Thank you, Dan. So in the next few slides, we're going to talk a little about how Model 9 sees things and how we think things should be done differently and how you can do things differently. So I think you're all familiar with the current system architecture, mainframe data management running on billable MIPS, consuming data from primary DASD space, different data types on the mainframe, and using FICON connectivity to write all of that to tape systems, whether they're virtual or physical, really doesn't matter. One of the problems with this architecture, it really doesn't allow anyone to access that data from outside the mainframe. So any tools you have for analytics, machine learning, BI, really can't enjoy that data unless you bring it back from tape, process it on the mainframe, make it readable for that open systems application, and then pushing it out to be consumed by the other application. So Model 9 sees the data management a little bit differently. First of all, we obviously support all the primary DASD out there, including tape systems, so we can read data both from primary disks and from historical archives that you might already have on tapes. Everything we do with Model 9 is non-billable MIP. So we're running on zip engines, and I'll talk a little bit about that later, about how we do that. But really, a bare minimum of our product is running on general processors, and almost everything is running on zip engines. We don't use FICON to send the data out. We're using tcppap, your OSA cards, in order to write to any object storage out there, whether it's on your premises or on the cloud. And we do not involve tape in that process. So there's no tape management. We're not trying to virtualize any tape systems. We're simply working with that object storage wherever it may be. Once the data is on object storage, it's available for any other cloud application or open system application to ingest that data, whether it's BI, analytics, machine learning, whatever insight you want to get out of that data. And whether it's historical or not, everything will be available on that object storage. So I want to make sure everyone understands what object storage is. I'll mention that in a sentence, and how it is used today in data management. So first of all, object storage is a new player in the market. I suppose all of you have noticed some vendors are already using it in the mainframe as well. But basically, it is a very scalable storage connected over TCP/IP and HTTPS. So encryption's built in. This object storage platform already exists for a couple of decades now. All storage vendors have them, and I'll show a quick view of that as well. Some vendors are using object storage as a next tier to tapes. So you first write things to tape, then you tier it down to object storage, maybe in the cloud, maybe on premise. Some of them are trying to transform their tape systems to also be some kind of object storage target for other things to write on. But object storage on itself really provide multiple tiers of its own. So whether it's hot, infrequent access, and even cold storage. And these tiers are dramatically reducing costs for that storage as well. So writing to cold storage is dramatically less expensive than hot storage. As I mentioned, object storage is here for a long time now. It has all the different functionalities you can think of, from replication, active-active configurations, warm, deduplication, compression, encryption, all of that is fully available today. And what we want to suggest is object storage really can be a full replacement to tapes and not just a different tier after writing to tapes. So this is like a quick view. It's not a complete list, but it contains all the major cloud vendors, including IBM, all the storage vendors out there. And there's a couple of names here I'm guessing you never thought a mainframe will be able to write to, right? So NetApp, Cohesity, MinIO, writing to Azure, really these kind of things on the mainframe are, I don't think everyone guessed that's going to happen anytime soon. But we suggest all of these are fully capable, and all of these are legit object storage to be used in your production environment. And obviously Model 9 can write to any one of these and more. So let's talk a little bit about data management simplifications. It is a high skill that needs to be acquired and a high learning curve today. The daily management of data management really talks about analyzing large amounts of logs in order to understand what happened last night. Some customers written their own automation in order to be able to analyze that log. And some customers simply don't analyze them because it's too complicated to do. So really, when they wake up in the morning, they don't know whether or not the last backup or archive policies finished okay or not. It's simply too hard to do in a lot of cases. There are sometimes large amounts of backups and archive jobs to keep track of. One backup will back up a different high-level qualifier, a different one will do different low-level qualifiers. It's really hard to keep up with all those jobs that back up your environment, and we suggest that can be done a lot more easier. There's also large databases on the mainframe to maintain all that metadata of all your backups, all your archives, all your tapes. All of that is being done on the mainframe itself, consuming more CPU and requires daily maintenance, backing up those databases, making sure they're recoverable, reorganizing them, recycling them, all these kind of things that are done today on the mainframe. Tape management, there are simply too many databases managing tapes. There's one on your hardware, there's a database there. There's another one for ZOS called the Volcat, managing all the tapes on ZOS. And there's another one managing all the tapes themselves by the tape management system. So really, at least 3 databases managing the same thing. And I've seen many, many cases where these databases go out of sync, especially at DR scenarios, when you don't touch those databases for a long time in DR, and really makes it hard. So again, even things like scratching, reclamation, recycling processes, all of these are daily stuff you need to do for your tape management, just in order to be able to have tapes on your system. So what we suggest is all of that really should go away. You should have a rich management UI that allows you to see at a glance what happened last night, whether or not there were any errors. You can drill down, figure out which data set failed, why it failed, with clear messages and explanations that will help you make sure everything is done successfully. Obviously, all of this can also be automated, but sometimes you want to be able to have a look on your own and see what's wrong. This UI will allow you to define your policies, to see them all in one place, to be able to search for backups, for archives, and all while still allowing you to do all of that from the mainframe side as well. So a CLI, again, for listing, recovering, all of that should always be available. So a little bit about the MSU and CPU costs. Data management is a high CPU consumer, sometimes even running in your 4-hour rolling average peak, which actually increases your licenses and fees for different softwares. We think zip engines, first of all, should be used for everything possible in that environment. So encryption, compression, even sending the data, and even managing the metadata, everything should be zip eligible. We truly believe that managing huge metadata databases on ZOS for tape management and for your backup management is really not needed and is a waste. We have object storage available for us, and it's fully available and scalable to manage the metadata there as well. So the metadata is actually sitting with the data and not on the ZOS system that might fail and you need to recover. So everything is really adjacent to the data itself. And when you want to recover, everything is in one place that you might have replicated or not to a different site. Once you go object storage, really, there's no more need to recycle, to reclamation for scratches, reorgs of databases. All of that is simply not needed. There is a misconception that TCP/IP usage is going to be really high now that you're pushing all the data through TCP/IP. I'm going to show you in a second how this looks like before and after. So this is a nice slide showing data management running before and after working with object storage and zip engines and TCP/IP. So on the left, you can see data management part, the backup running on general processors. It's really the highest consumer of CPU. On top of that, you have some catalog processing if this is an incremental backup, with in this example it is, and there is zero TCP/IP usage on the before scenario. In the after scenario, you can see the data management process is dramatically reduced. Catalog is basically the same, and TCP/IP usage, while it's there, it's really negligible and it's almost close to zero. So if TCP/IP is configured correctly, really, it is not an issue at all for sending the data. As I mentioned, everything from encryption, compression, and all these kind of things are done on zip engines, and they're not even going through those OSA cards. So I want to show you a small performance example, because everything we say is with the assumption that moving to object storage has to be at least as good in performance and better. So I'm going to take an example of a Z15, two Z15 machines with 10 gigabit connectivity, 4 zip engines, and using mainframe side compression. So everything is going to be compressed on the mainframe, including data in flight encryption. So all of that will happen on the mainframe before sending the data out to the cloud. So this configuration, for example, can go as high as 2.5 to 3 gigabytes per second of throughput. Translated into the network throughput needed, as the compression ratio varies. This is a tricky one, but let's assume a 3:1 compression ratio. This is what will need to go over your network infrastructure in order to reach the object storage. So backup windows and archive windows really goes down dramatically. So for example, a dataset backup, 3 terabytes in under 30 minutes, full volume dumps of 11 terabytes in under an hour. So really very fast and very capable. And I'll show you how we do that and how we're capable of getting that much of performance out of your mainframe without consuming all that CPU in the mainframe. So I want to talk a little bit about how you can get the most out of your mainframe. This is going to be a little bit more technical, some more parameters, things like that, that you can use on your mainframe in order to get those things. So I mentioned performance always has to be at least the same or better. It is important to understand that the performance goal is throughput. Okay, this is not primary disk. This is not transactional work. Latency is less of an impact, and we make sure of that with our technology as well. I'll mention that later. The point is to get as much data as possible, fast as possible, to your target storage. So the mainframe today already has different OSA card throughputs, 1 gigabit, 10 gigabit, and even 25 gigabit OSA cards. Even if you have 1 gigabit OSA cards, that doesn't mean that's your maximum throughput. Multiple OSA cards can be multipath together, meaning if you have 4 1 gigabit OSA cards, we can utilize them all with the multipath TCP/IP parameter. This will force TCP/IP to actually send the data across all the OSA cards and not just a single one, which will allow you to get higher throughputs as well. Another interesting parameter that is available for TCP/IP is segmentation offloading. So some of the work TCP/IP is doing by default is splitting up those data that you're trying to send over the network, splitting those into smaller chunks. Segmentation offloads parameter really tells TCP/IP to offload that work into the OSA card CPU instead of the mainframe general processors. Another important thing to notice is the maximum transmission unit on the mainframe. The default is really low, it's like 512. And if you haven't touched that, you should really make sure it is at least 1492, and the higher the better if your network infrastructure support that. It goes as high as almost 9Ks. This will again reduce the amount of work that TCPAP and the OSA cards needs to do in order to chunk up those data chunks into smaller pieces. Mainframe side compression, whether using the ZEDC cards or the zip engines or on the Z15 where ZEDC is already generally available as part of the processors themselves, using that is very important on data management. So a lot of customers that don't have enough network infrastructure to push massive amounts of data, compressing it on the mainframe really doesn't cost you. So the ZEDC and the zip engines can do that with great ratios and reducing the amount of data being sent over network. On the other hand, keep in mind that you now have modern object storage available as your target storage. This means this object storage might have its own compression and maybe even deduplication capabilities. So we have customers with different object storage. They actually push the data as is without compressing it on the mainframe because they have enough bandwidth on their network and they know the target storage is going to do both compression and deduplication, which will get you really high compression ratios on that target storage. So everything is possible and everything is configurable really at the policy level. The next thing I just wanted to mention is HTTPS is key here when working with cloud. Maybe if you're working on premise, you can avoid encrypting the data in flight, but really for cloud, it's really important. And starting with IBM Z14 and up, really the encryption has been dramatically improved and really becomes not really significant for the added CPU cycle that is needed. And again, although they're on zip engines, the lower the better. So the next few slides, I really want to show you how we do things and how things should be done in order to be able to get those high throughputs from your mainframe, taking into consideration all the different aspects we talked about. So when we have, let's say, a backup policy that needs to go over, I don't know, a few dozen storage groups and millions of data set that needs to be backed up, the process seems a little bit like this, and maybe I'll use a laser just to show this. The first thing that's going to start running is the discovery process. So once you define your policy, which says go over all of my SMS policy and make the decision what needs to be backed up and what's not, based on management class, storage group, change bit, or whatever, this discovery is going to run on one of your LPARs. During the discovery process itself, data sets are being discovered and selected for backup. So even when the discovery is still running, backups are starting to run as well. And these backups will run on all the eligible LPARs you defined in your policy. So if you have a sysplex running on multiple CACs, you can scale out and utilize resources from both your mainframes and different LPARs. So everything from scaling up using more memory, more OSA cards, more zip engines can be used by Model 9, but even adding more and more mainframes is also increasing the resources Model 9 can use. So obviously each one of these mainframes are using multiple streams, pushing multiple backups in parallel to the cloud, allowing us to get very high throughputs. So I'm going to drill down now. So consider what we've saw up until now, and I'm going to drill down into a single agent running on a single LPAR. So we're taking data now from DASD and trying to push it out to the cloud. So we're going to have multiple backups running inside the Model 9 address space. We call the Model 9 agent. So different DFDSS actually running, and this is our data mover to move the data, running inside the address space, pulling data from DASD. And once this data is being pulled from DASD, it's being chunked up to objects that are going to be sent to the object storage. So there are multiple streams writing to the object storage in parallel, really avoiding those latency issues. So if you compare this to a tape system that is writing sequentially, you might have multiple tapes, which is similar to this scenario. Each one of them is going to be a single stream. So latency comes to play when we're using single streams. This is just the default chunk size we send to AWS. It can be increased, it can be changed within the product. So I'm going to zoom in and talk a little bit about that single backup issue. So while the agent is running multiple backups, I'm now just going to focus on a single backup and how it behaves. So getting that track level data from disk is happening within the Model 9 address space, but we don't go ahead and send any one of these blocks to object storage. That will be really a messy way to do that, and it's going to impact performance dramatically. So what we do is we take all that data and chunk it up into bigger chunks. So something that makes sense to send over network to the cloud. So by default, as I mentioned before, 5 megabytes. But you can see that everything happens in parallel. So these chunks are being built up in parallel and sent to the cloud in parallel. So this means even a single backup is capable of utilizing your entire bandwidth by sending multiple TCP/IP streams and not being hangover using a single stream. So this is a key difference between, the legacy softwares that works with tapes and working with the cloud. So you can really push vast amounts of data, even if you have a single data set being backed up. So the same goes for restore. So even restoring something, let's say you archived an important data set and you need to automatically recall it back to the mainframe. So Model 9 obviously fully supports that. And what happens really is a DFDSS job is starting in order to bring back the data. And we use a read ahead mechanism really to bring back that data from object storage, again, in parallel. So bringing back multiple chunks back into the Model 9 address space and feeding them to DFDSS. So there are always multiple streams from object storage reading the data back, which allows you to restore as fast as your DASD system allows you, and reducing the bottleneck from the object storage, and whether or not it's far or not is going to less impact the performance for restore. Okay, so before I drill down, I see there's no current questions. If there are, please let me know.
Ofer, before you continue, I just want to make it clear that we give during the session examples from AWS or cloud, but it can be IBM Cloud, it can be Azure, it can be on-prem. So we just need object storage as a repository, and all of the examples and everything in the use cases that we're talking about is relevant to either on-prem or off-prem.
Yeah, and we actually also support non-object storage. If you have any stand storage in your open systems or NAS, so any NFS or block storage, we can also work with that.
Ofer, there is a question. During restore process, do you create a temp dataset as input to ADR DSSU?
Yeah, that's actually a great question. Thank you.
I wanted to ask, but I thought it's better for the participants to ask this.
So really, when we write and read data, there are no temporary data sets. We take the data directly from DASD into the Model 9 address space and send it back and send it to to the cloud storage. So no temporary data set, no additional DASD on ZOS system whatsoever, both for restore and backup. I hope that answered that question.
Yes.
Great, thank you. So I'm going to talk a little bit about zip performance and what you can do in order to get the most out of your zip engines. So there is a misconception out there that zips can reach 100%. Well, I would start by saying that it can, but simply not for all applications. So you might have a number like 60% in your mind, which is something DB2 is limited to not use more than 60%. But if you take a Java application, for example, and run it on zip engines, it will easily drive that zip engines to 100%. On that note, Model 9 is fully written in Java. So everything we do, as I mentioned, is zip eligible, which allows us to utilize the zip engines as well, up to 100%. SMT is the next thing I wanted to note. So there are red books out there, and this is just a quote from one of them. SMT2 is really the ability to better utilize your zip engines by sending at least 2 threads per core. So this allows a better utilization of zip engines, and it is exactly and fully the right thing to do when you're trying to push massive amounts of data with your zip engines. So SMT is really good for data management. It might be less good for transactional workloads, but definitely for data management, SMT is the way to go. So sometimes you get to see customers reaching those 95 something percent, and it's hard for them to get to a 100. Turning on SMT will definitely get you to that 100. So spilling over to GCP, that's a real thing with zip engines. And it goes both ways. Sometimes you do not want to spill over to GCPs at all, because that might affect your licensing or your MSU usage. But sometimes you do, because you don't have enough zips and you have plenty of general processors, and you do want to spill over for zips. So really, at a global level, this can be either enabled or disabled at the system level in IEA OPT using the IPP honor priority parameter. Simply specifying that sets the default for all application running on your z/OS LPAR, whether or not spillover to GCPs should happen. But it is very important to understand that this can also be controlled at the service class level. So for example, if you do not want Model 9 to spill over to GCPs, you would specify that in the Model 9 service class in WLM that data management should not spill over to GCPs. On the same manner, as I mentioned, sometimes you do want to spill over to GCPs, and the default spillover is kind of minor. So z/OS in general does not spill over massive amounts of zip eligible work into CPs. But the zip AWMT parameter in IEA opt actually allows you to control that a little bit better and really say how frequently should z/OS look for work that can be spilled over to GCPs. So increasing or reducing this parameter can really change those spillover values if you're interested in them. Just for a note, keep in mind that discretionary zip workload, if you have zip engines, will not spill over to GCP regardless of what you do, okay? Okay, so this is like a quick example of how you would expect data management to look like. So this is the workload that does encryption, compression, sending data out. You would expect at least 90% of that work to run on zip engines and not the other way around. You can see only 6% out of what everything that data management did here actually ran on GCPs. The only thing we run on GCPs is really the bare IOs in order to read the data from DASD. And as you know, mainframe is very good at scheduling IO with very little CPU usage. All the rest on ZCP engines. As you can see here in my example, only 1 second has been spilled over to GCP in this scenario. So once we have that in mind, let's talk a little bit about sharing data with other applications outside the mainframe. Today, using ETL processes consumes a lot of CPU on the mainframe and a lot of time. It's complicated, and really, you have to do all the transformation on the mainframe side. So getting those vSAMs flattened out somehow to a CSV on the mainframe and then sending it out, or using different ETL tools that does that as well on the mainframe. This really forces you only to send a small subset of the data in your mainframe out. And you really have to pick and choose only the specific data that your application really needs in order to process it on the mainframe and send it out. I would say sometimes even customers have developers working on unloading the data from their vSAM COBOL applications and flattening them out into readable formats that can then be digested by tcppap, FTP, with or without encryption. That really takes a lot of resources. Model 9 sees this process very differently. So first of all, we think there should not be any CPU waste on the mainframe side when pushing data outside of the mainframe. As I mentioned, everything can be zip eligible. So this allows you to push vast amount of data in the raw mainframe format without any processing on the data itself outside of the mainframe. So you can send all your historical data, maybe all of your historical DB2 images, all of your current primary data, send it all out to the cloud very efficiently and very fast while including compression and encryption. Once the data is in the cloud, all the transformation can happen there. And Model 9 provides and suggests that's the way you should do it. So let's say you moved a VSAM file, a KSDS out to the cloud, and you want to transform it. Our transformation service will allow you to do exactly that, specifying the COBOL copybook that VSAM is using and the VSAM itself, producing a CSV file in UTF format, and doing that all outside of the mainframe without consuming a single MIPS in order to do that. So this really opens up possibilities. You can run data transformation all day long. You don't have to consider whether this is now your peak time and you only have to do that on the night batch because that's where you have enough CPU to do all the transformation. You can really push data all day long and transform it whenever you need to. Okay, so let's see how that translates into costs. The different components available for cost reduction are, first of all, the MIPS reduction. So when we convert the ordinary or the legacy data management into the modern data management, we provide at least by minimum a 60% reduction in MSUs for data management CPU consumption. So if that's running in your peak hours, this is going to reduce your licensing dramatically for MSU consumption in generally. If not, it might free up resources for you to run other workload on those hours as well. Secondary storage, well, using proprietary tape systems or proprietary mainframe system versus commodity that are out there in the open systems in the cloud really shows very good cost reductions as well. And this is a key factor. There's also tcppap versus FICAN, again, proprietary protocols versus open protocols. Everything is much simpler. Using encryption does not require anything special. It's just, you know, another letter you need to specify and you have encryption automatically enabled. You can replace your backup software. You can replace your other commodity software, tape management, reporting, encryption that you use today in order to write to tape systems. All of that can be replaced with a single software, which much lower licenses fees than the rest. The last thing on this component list is really ETL tools. We suggest that can be done very easily with the Model 9 software alone, without the real need for ETL heavy running on the mainframe, consuming more CPU and making it more complicated to move the data. So if there's no questions up until now, let me see. Yeah, I don't see anything at the moment. We're going to move on to a real life example from really a US bank that did a VTL replacement for the mainframe. This is the before diagram showing how the architecture looked like before. So they had two mainframes, one on the primary side, one on the DR. The DR one was passive, so just in case of a disaster recovery, that would get activated. They have a virtual tape system and an automated tape library that was more for cold storage, and the virtual tape library for more hot data, with replication to the DR side with an exact same configuration. The new diagram, when working with a modern data management software, so the left side of the mainframes is basically the same, working with AWS Cloud. So the cloud is out there, and while you can replicate the data in AWS itself to multiple regions in AWS, AWS by default, as a secondary target, replicates the data over 3 different sites by minimum and giving you high availability. So in this case, using encryption and compression on the mainframe side, data was backed up into Amazon S3. Using lifecycle policies, even move that data into colder AWS storage called AWS S3 Glacier. And the cost of this storage is dramatically less than any other storage, both on cloud and on-prem. We also have the Model 9 management server running in the cloud. And this is what provides the web user interface where you can define and work with the product very easily. It doesn't have to run on AWS. It can also run on-prem. Everything here can be on-prem. This is just this customer who chose to work with AWS. I mentioned our Model 9 transformation service. This is also running on AWS, and this is the component that allows you to transform the data from its raw format in object storage into readable formats that can then be ingested by any other analytics, machine learning, or business insights that you might want to get from the data. So Dan, I'm going to let you go over this slide.
Thank you. So this is an example from this customer and cost comparison between the traditional approach and Model 9 solution. So as we said, we are a data management software. So there's the license for our software and also a license for a storage repository, either on the cloud, if it's IBM, Azure, AWS, Google, whatever, or on-prem if you have preferred storage vendor, that is fine, versus the traditional approach, which here I written down everything in this specific customer example it was without the ETL tools, but you can see the MSU reduction, the VTL replacement, ATL replacement. There is savings associated with power, cooling, and real estate. You don't need FICON connectivity. Everything is tcppap, which is cheaper. You don't need tape encryption software, tape management software. We replaced the backup software as well. By the way, we have a session in 2 days talking about CA replacement with Model 9, giving examples. And again, there is a lot of customers today that are looking for an alternative, and Model 9 is that alternative. Now, this is a 3 years savings with a customer that has 40,000 MIPS and 1 petabyte. If we change it into 5 years, this is the cost savings. So as the term is longer, you can save much more. The savings is significantly more. Any question, something that you want us to answer? I hope with the time we are okay. We have like 15 minutes for Q&A. Okay, so this was a session to talk about cost reduction. We tried to explain all of the different components. We gave an example from a real customer. If you want us to give you a specific sizing and price reduction that we can do for you, please reach out to us. Either send me an email, dan@model9.io, or contact@model9.io. You have the details in the GSE. Jeff, do you have any questions? You told me that you hope to learn more about what we do.
I definitely, I do have a question. It would be helpful if you could give some more information about Cloud9. I think that would be useful for everyone.
You mean about Model 9?
Sorry, Model 9. I do apologize. I've been too involved in the cloud with your presentations.
No, it's fine. It's fine.
I'm in the cloud there. So no, sorry about that. The question is about Model 9. I do apologize.
Okay, so Model 9, it's a data management software. So what we do is we are a software that enables to take data from the mainframe and transform it into object storage. It can be on-prem or in the cloud. We are an alternative for backup software for mainframe, if it's CA or HSM, replacing the VTL and ATL for a customer. And doing everything around the data mainframe modernization and reducing the cost and the billable MIPS.
Okay, thank you. That's very helpful. Okay, I would encourage that there are 31 participants, and if you've got any further questions, please put it on the chat. If you don't want to write it, just put a thumb up and I'll unmute you. I'll give you a couple of minutes and let's see if we can encourage or entice anybody with some further questions. I've actually found it very, very informative. So.
Me too. I love listening to Ofer speak about mainframe.
Okay. Right. I think I don't think there's any more questions. I will say the maximum participants was 34, and we've still got 30 participants on. So I think you guys have kept the audience. So well done for that. So it must be a really good presentation of interest to the folks who have joined. And I would like to thank everybody. But I want to start where I finished. And that is, if you could, please, could you fill in the feedback? It's very important. Guide Share basically thrives on that, and it actually decides how we're going to form the next Guide Share event. So please, can you fill it in? If to make it easy, rather than type it in, if you go to the agenda, click on the actual session, and at the very bottom of it is actually the link for the feedback, and it fills in everything. Dan, you also commented if they need to get hold of you, i.e. they've got some questions afterwards, the same place. If you click on the speaker, you also have Dan's direct email, and you can actually contact him direct. And again, just to remind you, the session is 4AR. The other thing, and I know Dan touched on it, and I would like to remind everybody again, they have a session on Thursday, the 12th of November, and that's at 10:30, the same time as this. And it's a customer study case about replacing legacy CA products with cloud data management for mainframe. So again, I think that's your final session as well. And I am the chair. My last thing I'm going to say is the event supports a fantastic charity, which is to do with the NHS. We would encourage you to give to this. And I don't know if any of you were on Mark Wilson's keynote speak yesterday afternoon, but he said anybody who puts over £100 will actually get a formal mention. So I just want to raise that. I don't have anything more to say except thank you very much. Thank you to Model 9 for doing a fantastic presentation. And yeah, thank you very much. And I'm going to bring this to a close.
Thank you, guys.
Thank you, everyone.
Thank you. Bye.